Hello, my name is Matthew Zimmerman, and I'm here today to introduce you to Farsounder's 3D forward-looking sonar technology, and specifically considerations that are relevant to you, yacht managers, technical superintendents, refit and new build project managers, and build captains. Please feel free to ask any questions along the way in either the Q&A panel or the chat, and we'll be certain to answer them at the end of the presentation. In a nutshell, our products make navigation safer. To begin, let me give you a very brief overview of our technology to set the stage for this discussion. If you want to dive deeper into the details, I encourage you to check out our website and some of our past webinars. So why 3D sonar? Groundings and collisions cost lives and money and have significant environmental impacts. Farsounder products provide the most essential navigation information, which is what is underwater ahead of the vessel. Echo sounders look straight down and won't see that rock ahead. Radars and cameras look out above the water. Again, these won't see the rock below. To be an effective navigation tool, a forward-looking sonar must have a wide field of view, a fast update rate, and be capable of sensing from the seafloor all the way to the sea surface with a single ping. This is exactly what Farsounder's unique technology can do. Here is an example of our product's 3D sonar display. I helped found Farsounder over 21 years ago, and we've been shipping true 3D sonar products to customers all around the world since 2005. Our customers use our products to avoid a wide variety of navigation hazards, including icebergs when navigating in polar regions, large whales, rocky pinnacles, shallow sea bottoms and coral heads, lost shipping containers floating at or below the sea surface, and other unmarked obstacles. Our products are intended to provide the yacht operator with a clear picture of what is underwater ahead of the vessel. Farsounder's range of models can operate from 350 meters to 1,000 meters ahead of the yacht. That's more than half a nautical mile. These systems can map the seafloor out to at least 8 times the depth of water below the transducer module, as well as detect in-water targets out to the full range of the sonar. And our software includes both the chart overlay and 3D perspective views that you see here. Your guests on board want to access the most exclusive destinations, and our products can help you do that more safely. One exclusive adventure that is becoming sought after is traveling through the Northwest Passage. As more yachts are accessing polar regions, some of them are exploring this route. Much of the route has little to no chart data and includes ever-changing ice formations. This is an obvious use case for forward-looking sonar. As an aside, the Canadian Hydrographic Service is actively working to improve their charts and is even using some sonar data collected by one of our customers along this route. I'll talk more about data recording options in just a few moments. Another popular destination is the thousands of beautiful reefs, islands, and atolls in the South Pacific. In many cases, the main transit lanes are fairly well charted, although the crew of the USS Guardian would probably beg to differ after they grounded in the Philippines. However, all those little coves and lagoons where the guests on board want to access, those vast areas are practically uncharted. Here's one such example in Papua New Guinea. As we zoom in, we see a little bit of detail, and as we zoom in further, there's almost no additional detail about the areas less than 200 meters deep. Clearly, the chart data is no more than just a vague general reference for these types of areas. Yacht captains need to use more tools in these locations, positioning a visual lookout on the bow, sending out a tender in advance, or using forward-looking sonar to find and map safe passages. Yet another polar destination rising in popularity is Antarctica. If one considers the total number of people visiting Antarctica as compared to the immense size of the continent, a visitor would think that they would be exploring virgin coastlines and exclusive anchorages. However, in practice, most of the yachts and cruise ships visiting our southernmost continent stick to a relatively small and well-known itinerary. Ask the reason why, and the answer is basically, well, we came here last time, it didn't sink, so hopefully we won't this time, and if we do, there will be other ships around to rescue us. Antarctica is yet another location with very little charted coastlines. Plus, it has an ever-changing ice shelf and icebergs. Once again, navigating in this environment is a perfect application for forward-looking sonar. With added confidence of knowing what's ahead underwater, a yacht captain can increase their ability to safely access a more exclusive shoreline, getting a little farther off the beaten track at the bottom of the world. I don't want to imply that forward-looking sonar is only really valuable in polar regions. These are just dramatic examples. We have customers using our products across all latitudes. So let's look at some other capabilities we offer. Our focus has always been on being a real-time sensor looking out ahead of the vessel. However, our products also include our local history mapping feature. This is essentially a bathymetric survey of where the vessel has been recently. In the future, we envision being able to store, recall, and share this data across a fleet. One use case of our local history mapping capabilities is performing an anchor survey. When accessing exclusive destinations around the world, a yacht captain often needs to drop anchor in places that may appear to be good anchorages, but are not official anchoring locations. In these cases, it's a great idea to perform a quick anchor survey before dropping the hook. This way, the captain can choose the optimal location. More importantly, while the ship lies on anchor and it sways with the tide, winds, and the current, the crew can monitor the location of the stern relative to any shallows surveyed with the sonar. While we're on the subject of use cases, another application where many captains want to increase their situational awareness is approaching the shore at night. Before even making that anchor survey we just talked about, they need to reach the anchorage, get inside that protective cove, and position the vessel for a safe and comfortable night. Just like they use night vision cameras above the water, forward-looking sonar provides an additional level of safety by detecting underwater obstacles that can't be seen visually. Even if the water is perfectly clear, an extra visual watch on the bow doesn't add much value in darkness. In another similar scenario, the captain may have easily navigated through a barrier reef into a quiet lagoon for a lazy lunch on anchor. Then, when the guests ask to stay there through dinner, the captain now finds they need to navigate back through the barrier reef at night. Not only will the real-time capabilities of a forward-looking sonar come in handy, but Farsounder's local history mapping will also provide a recorded path that can be referenced on the way out. So our local history mapping capability records locally on the Farsounder computer. However, I also hinted at other recording capabilities as well. I want to take a few moments now to talk about this in greater detail. In addition to local history mapping, which is a real-time feature inside our main software, our customers can choose to participate in our expedition-sourced ocean data collection program, whereby they can record what the sonar sees and contribute the data to a global community via the IHO and Seabed 2030, a global initiative to map the world's oceans. This is one simple way that the yachting community can give back to the greater marine community at large. Our ocean data collection program is an opt-in program for select customers who are traveling to exotic locations, interested in contributing to science, and want to participate in making the system better. As part of this program, we send participants a USB hard drive, which records all the raw data received by their system. When the drive is full, it is sent back to Farsounder for compilation. I want to stress that this program is an opt-in program. Otherwise, our systems are not recording anything that is sent back to Farsounder. Here's a map of some of the data collected by our customers. To date, we have over 50 terabytes of sonar data that's been collected, with another 70 terabytes of drives in the field. This data is included in the continual testing of our algorithms to allow for more examples of different sonars, different locations, and different conditions. A subset of this data has been submitted to the NOAA and IHO through our work with the IHO's Crowdsourced Bathymetry Working Group. Farsounder is an official trusted node of the IHO's Data Center for Digital Bathymetry, and all contributions to the IHO's database are available for public use, and through the IHO's database, it's also included in Seabed 2020. So how could such crowdsourced bathymetry be useful? Our recorded data can clearly detect major features and navigation hazards. This information is invaluable if the area were not charted or not recently charted. Hydrographic offices can look for discrepancies and use this insight to plan official survey needs. This is exactly what the Canadian Hydrographic Service is interested in. Their work on updating chart 7053 is their first proof of concept. In this case, they're actually incorporating the Farsounder customer collected measurements directly. Here's another example even closer to my home. This animation shows some of our data from the Narragansett Bay here in the northeast of the United States. The US has some of the best charts in the world. As it turns out, even in this well-traveled area, NOAA does not have complete coverage. The light blue spots represent gaps in the data NOAA has available and contributed to Seabed 2030. We are currently in communication with NOAA's National Centers for Environmental Information about how best to contribute data we've collected in areas missing this NOAA coverage. Hopefully by now, you are all convinced of our sonar's benefits and applications. So the next question is, which Argos model is right for you? Each of the Argos series sonars use a product-specific in-water sensor, which we call the transducer module. The primary difference between these units is the number of elements in their receiver array. More elements result in a higher resolution sensor capable of operating out to longer ranges. The Argos 350 transducer module has a receiver array with approximately 50 receiver elements. The Argos 500 transducer module has approximately 100 elements in its array, while the Argos 1000 has a receiver system with approximately 200 elements. A Farsounder supplied cable is used to connect the transducer module to the power module, which is our inboard equipment, and features an underwater wet mateable connector, allowing the transducer module to be installed or removed by a diver. The software is the same on all models, and Farsounder's suite of navigation products are installed on a wide variety of vessels, and they consist of the Argos 350, Argos 500, and Argos 1000 sonars. The primary differentiator between our models is range, hence our cleverly named product models. These 3D forward-looking sonars have a maximum operating range of 350 meters, 500 meters, and 1,000 meters, respectively. Maximum operational speed and field of view also vary accordingly with each model, as you can see here in this chart. Okay, so you want to add one of our forward-looking sonars. That's great. Let's go through the general process and considerations of how our equipment is installed. We do about 50% refits and about 50% new builds. The general installation process is the same in both cases. Our engineers will work with the yard or naval architect to ensure your installation design is effective, and we offer complimentary drawing review services. My team is happy to support you in the installation design effort even before we have an official order. To begin, we supply your design team with our installation design guide, which explains the general installation design requirements and the installation process for all of our systems. This document includes a simple checklist that guides the naval architect through each detail of the design. As a companion to the installation design guide, Farsounder has also developed drawing packages for each of our products. These drawing packages include mechanical drawings of our products, components, as well as a fairing concept drawing, and examples of how to integrate the fairings into various hull types. These documents can serve as the basis for the yard's specific design. As I mentioned, we offer complimentary installation drawing review services, And in many cases, shipyards submit their drawings to Farsounder for confirmation that all guidelines have been followed. You'll likely keep these drawings as part of the vessel's documentation. Once the installation design is approved, fabrication of the physical installation can begin. The process culminates with equipment put in place and system commissioning. Most of our customers utilize a fixed installation design, which has the advantage of being very simple and has no moving parts. Over the last 20 years, we've refined our installation techniques with a straightforward design approach. Though every vessel is unique, our simple process is applicable to a wide variety of hull types, and we do this all the time. A fairing is constructed, which is essentially a tube, and the fairing tube is integrated into the hull. The sonar's transducer module is then installed from the exterior of the hull. Depending upon the sonar model and the hull material, the fairing tube can be circular or rectangular, steel, aluminum, or composite. For the most part, all of our customers' fixed installations follow the same general concept. Inside the fairing, the transducer module connects to our cable with an underwater wet mateable connector. That cable runs in a conduit up above the waterline. This design even allows for a diver to disconnect and reconnect the unit underwater if needed. I've done this personally, so I know it's possible, not just designed in theory. Let's take a quick tour of how the fairing has been integrated into various hulls. Here are some examples of vessels with large bulbs. The two hulls shown on the left and right photos are both ice-class passenger vessels. It's even possible to install on a bulbous bow to the side of the stem. We found this picture of one of our customers on the marinetraffic.com website. Of course, installation is possible on vessels with smaller bulbs. The large picture shows an Argos 500 installed on a 62-foot composite hulled Nordhaven. Here's another ice-class vessel. This time, an example of a straight bow with an Argos 500 installed on the center line, and yet another ice-class hull with an Argos 1000 installed. Here are a couple more examples of raked bows showing the fairing installed on the center line with the top of the fairing tube mated flush to the stem, but that tube can also be installed on the side of the stem if preferred. With this vessel, we see an example of a fairing that was installed on the center line forward of the stem. This vessel was a quick refit and the stem was not cut. Only a small cable penetration passes through the hull. Inside the hull, the cable runs in a conduit above the waterline to prevent any water ingress. Some customers also install a dolphin camera on the bow. Locating the camera housing below and behind the sonar prevents turbulence generated by the camera housing from interfering with the sonar. And here's one last example of a fixed installation on a vessel with a raked bow. This is for an Argos 350 that was refit on a 72-foot Princess, which is a composite hull semi-planing vessel. The curved face of the Argos 350 fills that front opening. Of course, a few of our customers do prefer to use a hoist-based installation. This configuration is useful for ice-breaking vessels or other special applications. The example on the right is the RSS Sir David Attenborough, which is an icebreaker with an Argos 1000. This same hoist design was used on Le Commandant Charcot, Ponant's ice-breaking cruise ship. The Argos 350 is much smaller and designed to fit inside a standard 10-inch diameter sea chest. When intended for use with a hoist, the unit can be supplied with its connector on top rather than on the rear of the unit. There are blind-tapped mounting holes integrated into the top of the transducer module for connecting to the hoist. There are also blind-tapped holes on the bottom to allow for attachment to an exterior cover plate for the sea chest. Our partner, C4R Maritime Solutions, who supplied the large hoist for the Sir David Attenborough, has a smaller, off-the-shelf hoist design specifically for our Argos 350. Of course, our unit can be deployed with any suitably sized hoist mechanism with a simple adapter plate to mate between the hoist and the transducer module. C4R solution allows for clean lines and can be made flush to the hull when retracted. In addition to our complimentary installation drawing review services, we have another program designed to facilitate easy installation of our equipment. This is our Sonar Cable Advanced program. In many cases, a yacht owner's team is interested in including a far sounder sonar in their new build. Oftentimes, however, hull construction is completed before the owner's team has made final selection of electronics and contracted with an electronic supplier or integrator. In these cases, the sonar's installation design is then treated much like a refit project, even if the hull has never entered the water, because the hull design must be adapted for the fairing, adding time and customer costs to the installation. As part of this program, Farsounder offers advanced delivery of our sonar connection cables at no charge for any qualified new build that includes a fairing for one of our sonars. In this way, it's easy for the owner's team to include the sonar system when they are selecting the rest of the navigation electronics. The benefit to the owner's team is this program reduces the cost of installing the sonar, making this unique technology more accessible to a greater number of users. The benefit to the yard's team is by adding the fairing for an Argos sonar early in the process, there's little additional cost to the hull. This allows the yard to offer yet another value-added feature to their customers, and including this option on the vessel is one more way the yard can demonstrate their commitment to supporting the latest innovations in safety. When the Farsounder sonar is ordered, the cost of the cable is included in the base package and simply considered delivered in advance. In the case that the sonar is not ordered, there's no charge for the cable. However, the cable and fairing are pre-positioned and allow for easy addition during a future refit. Aside from the physical installation, integration of the sonar into the bridge system is also important to consider. At the most basic level, Farsounder systems can be integrated via standard video matrix, allowing the Farsounder bridge computer to be displayed and controlled from a number of bridge stations. Boning, Team Italia's iBridge, and Telemar's T-Master all include this capability as part of their standard options. For some users, this is considered a complete integration and done. A more tightly integrated solution utilizes a client-server architecture. In this type of architecture, the bridge computer connects to the sonar hardware, performs all the sonar processing, and provides the primary user interface display. It also acts as a network server, which supplies the processed sonar data to clients, which can offer display and/or control of the Farsounder system. Wärtsilä's Nakos is a well-known ECDIS which includes this native capability. QPS offers a direct integration from its Kinsey software, which can be used to develop your own charts and sophisticated survey plans. We hope to announce additional integration partners in the future. For specialized applications, we also offer an SDK, software development kit, which allows developers to add client capabilities to their own proprietary software. This is how the direct integration with Nakos and Kinsey were implemented. Another option for adding a custom bridge experience is via our software's built-in support for Windows hotkeys. The intent is not that users would add a traditional keyboard for day-to-day activities. Rather, this interface allows for any third-party device, which appears to Windows as a keyboard, to control our software. This makes it easy for custom foil panels and touchscreen controllers, which are physically designed into the bridge to easily connect to the Farsounder system. As you can see, we offer various methods of enabling varying levels of integration. And our global dealer network can work with you to implement your ideal integration solution. And of course, Farsounder's engineering team is also always happy to advise as well. After your Argos navigation sonar is installed, our relationship with you isn't over. We want to make sure that the bridge crew is getting the most out of your investment. We pride ourselves in making our systems easy to use and simple to understand. However, that doesn't mean that users won't benefit from some training. All Farsounder customers have complimentary access to our online, on-demand training, which includes both an end-user class and technician training class. Since launching these courses about 16 months ago, participant feedback has been overwhelmingly positive. We really spent a lot of time making sure these classes were easy to follow and explained things clearly. Most participants reported that our classes were better than most others or the best they've ever taken. During commissioning, our dealer's technician should have installed the latest software for your system. However, our development team is always working on improvements, and we generally have 3 to 4 software releases per year, and we'll send email notifications whenever we have a major update available for your vessel. Please be sure to give us 1 or more crew contact email addresses so that we can ensure that they are notified about these updates. And of course, should the crew have any questions or need assistance with software updates, our support team is here to help. We offer remote assistance easily via a TeamViewer connection to the Far Sounder Bridge. Of course, after the system is installed and running, you'll want to consider the total cost of ownership to ensure the system keeps running well. We've designed our systems to require very little maintenance. Aside from the aforementioned software updates, the only general maintenance tasks are to keep the fans and the array face clean. There are fans inside the power module and bridge computer. Like any other electronic system, you should check for excessive dust periodically. Depending upon your environment, you may want to clean the fans every 6 to 12 months. As for the array face, excessive marine growth will impact performance. Customers who are underway frequently and operate in colder waters find they only need to clean the array face once every year or so. Vessels that sit mostly at the dock in warmer waters may need to clean the array more frequently. If you wish to reduce biofouling on the array, we recommend applying Prop Speed's foul-free coating. Applying this coating can greatly reduce the array cleaning needs. And that's it. There's not a lot to maintaining the system. At the end of the day, our products are designed to help you minimize risk while navigating. Surely, reducing the likelihood of crew, guests, and vessel casualties is important. However, it is important not to overlook environmental costs from groundings in sensitive areas as well. And many of our most sought out exclusive yacht destinations are in these sensitive areas. The Great Barrier Reef, the Aleutian Islands, the Galapagos, Antarctica, just to name a few. There are many examples of cleanup costs and penalties from damage from ships running aground in such locations. Historically, some of these, from relatively small accidents, have been in the tens of billions of dollars. As a quick aside, reducing environmental impact was one of my team's early motivations when developing our technology. How could we help vessel operators avoid hitting rocks and avoid hitting whales? It turned out there was a commercial demand for such capabilities, which led to the development of our products today. Clearly, keeping your yacht in operation longer and more safely makes economic sense. I know I've covered a lot of content, and I hope you found this interesting and worthwhile, so thank you for your time. Once again, my name is Matthew Zimmerman from Far Sounder, and I'm happy to answer any questions that you may have. I saw a couple questions pop up during the presentation. One question was, if the location data has to be shared, will it be anonymous? And I think that was in reference to the data that's submitted to the IHO for the global community's use. It depends on what the customer wants. We can provide the vessel ID to the IHO, or we can just mark it as anonymous. So it depends on how participants care to participate. There was another question, are you working on any sort of augmented reality, something that can be worn by a helmsman at an outside control station? And that's a great question. We don't have anything that does that today, but we have been working on a few little fun side projects to test out some of these capabilities, looking at little web apps for phones or for the Oculus Eye camera systems. We don't have anything today, but it is something that we talk about. I mean, we're engineers here at Far Sounder, or at least the engineering team is, and we like these types of fun tools and technology. So we're always exploring what else can we do with our systems. Are there any other questions that came up? I know my colleague Evan was trying to curate those as they came along.
Hi, Matt. Yeah, we had a couple others that I saw pop in there that you might have missed. One of them was about the training, and is that available to the public? And how can people learn more about that?
Great question. You can access our training program via the web at training.farsounder.com. And a link to that is also from the main menu of our primary website.
Another one that came in was about the purchasing process. Like what are next steps if someone's interested in getting a quote and finding more about purchasing the system?
That's a great question. We have a dealer network all over the world with a lot of dealers in lots of geographic locations. As you know, the yacht market is pretty big in Europe. We have all the major integrators and dealers carry our equipment: Italy, Netherlands, France, Germany, Spain, Portugal, Turkey, and so on. We have a pretty comprehensive dealer network. They can provide you with official quotes and will supply you the equipment and commissioning services. And all that information is available on our website.
And one more that just came in was a question about what kind of charts can the system display? So what kind of ECSs do we do? Time zero, transits, etc.?
Sure, great question. So with our current software, we support the standard S57, S63 format charts by default. This is the format that's used in most ECDIS systems on board larger vessels. And this chart data can be supplied by a variety of suppliers. So like AVCS is one chart database from the UK that a lot of our customers use. We happen to use a kernel from a company called Navtor. They're another popular chart distributor, and we can interface directly with the Navtor chart hardware tools that they have on board. But you can use S57 and S63 from any supplier. There is a UPN number in our software that you give to the chart supplier, and they use that to encrypt the charts specific for the Far Sounder station. Many of our customers that have an ECDIS on the bridge find that they already have a chart data license that can be applied to the Far Sounder system. In some cases, they've licensed a chart data for the entire bridge, regardless of number of stations. And in other cases, they may have one or two spare station licenses available that they can apply to the Far Sounder station. So in many cases, customers find they can add chart data with no additional cost to our system. In the past, we also supported CMAP Professional Plus. It's now I4 Insight Professional Plus. We still support that in a legacy state, but a lot of the new chart overlay and local history mapping features that are coming out in the near future are only going to be for our S57 and S63 format chart engines. Okay, well, thank you everybody for taking the time to join this webinar. I hope you found it interesting and it was worth your time. As always, please feel free to email or message us on social media if other questions come up. You can reach us at info@farsounder.com or contact me directly, matthew.zimmerman@farsounder.com. Thank you very much, and I hope you have a great rest of your day.